Back to my channel. I am A. Purna Seshisan, Department of Information Science and Engineering, student of SVC Bangalore, USN 1VE 22IS001. Subject is DD and Co. Today, the main topic of our presentation is Introduction to Digital Electronics. The name itself tells we are going to learn about what is electronics and what comes under electronics. That is, binary logic system, binary functions, Boolean algebra, Boolean functions, logical gates, and combinational circuits, sequential circuits, and finally digital electronics application. Let us see one by one in detail. Introduction to Digital Electronics. Digital electronics is a branch of electronics that deal with the study of digital signals and systems. It involves the use of binary digits to represent and process information. The binary digits are basically 0 and 1. Digital circuits are built using electronic components such as transistors and logic gates. Let us see why we need digital electronics when we have analog electronics. Digital electronics offers several advantages over analog electronics. It provides better accuracy and precision in signal processing. It allows for easy storage, manipulation, and transmission of data, which is not possible in analog systems. Binary number system. The binary number system is foundation of digital electronics. It uses only two digits 0 and 1 to represent numbers and information. Binary numbers are used to represent digital signals and perform logical operations. So these are binary numbers, which is in the form of 0 and 1. So 1 is represented as 0 in the form of binary in the computer system, and 2 is represented as 1 and 0, and 4 is 0 1 0, 8 is 1 0 1 0, 16 is 0 1 0 1 0, and so on. So this is how binary numbers are stored. So to find the binary numbers, we have a separate system that is nothing but the binary number system, which converts all the decimal numbers in the form of zeros and ones. That let us know in that next session. At present, this is the basic introduction of binary number system. Logic gates. Logic gates are fundamental building blocks of digital circuits. They perform logical operations such as AND, OR, and NOT. Common logic gates include AND gate, OR gate, and XOR gate. So these are the basic logic gates. OR gate. OR gate is nothing but when both the inputs are 0, the output will be 0. When either of the input is 1, the output will be 1. For example, if input A is 0 and input B is 0, the output will be 0. If input A is 1, input B is 0, the output will be 1. If input A is 0 and input B is 1, the output will be 1. It means that it's a basic addition, mathematical addition. So for example, we can take as 1 plus 0 is nothing but 1, and 0 plus 1 is nothing but 1. 0 plus 0 is nothing but 0. So this small implementation represents OR gate. And NOR gate. NOR gate is abbreviated as not OR. Means whatever the output of logic gate or logic OR gate will be complemented. And that complemented gate is nothing but NOR gate. AND gate. AND gate is nothing but a mathematical multiplication. If we take a truth table, A is 0 and 0, the output will be 0 because 0 into 0 is 0. And if we take a truth table, A is 1 and B is 0. 1 into 0 is nothing but 0. So output is 0. If A is 1 and B is 1, 1 into 1 is 1. So this shows the AND gate is a basic mathematical multiplication. So when both the inputs are odd, so that's nothing but when both the inputs are 1, the output will be 1. When either of the input is 0 or when both the inputs are 0, the output will be 0. This is called AND gate. And NAND gate. NAND gate is abbreviated as not AND. That's nothing but complement of AND gate. And XOR gate. XOR gate is nothing but exclusive OR gate. So this XOR gate, XNOR gate is nothing but universal gates. They can represent any logic gate such as OR gate, NOR gate, and AND gate in the form of XOR gate and XNOR gate. Buffer. Buffer is nothing but anything is the input that will be the output. For example, if input is 1, output will be 1. If input is 0, output will be 0. NOR gate is nothing but the complement of buffer gate. So when input is 1, the complement is nothing but 0. So NOR gate output will be 0. When input is 0, the output will be 1 in case of NOR gate. Boolean algebra. Boolean algebra is a mathematical framework used for analyzing and designing digital circuits. It involves the use of logical operators such as and, or, and not. Boolean algebra helps in simplifying complex digital circuits. So, we have discussed about logic gates before. So, this is how the truth table looks for AND gate, NOT gate, and OR gate. So, I have told before, when either of the input is 1, the output will be 0. No, like when either of the input is 0, the output will be 0 in case of AND gate. Only when both the inputs are 1, the output will be 1. In case of OR gate, only when both the inputs are 0, it will be 0. When either of the input is 1, the output will be 1. In NOT gate is nothing but complement of buffer gate. So when input is 0, the output will be 1. When input is 1, the output will be 0. So this AND gate, NOT gate and OR gate can be represented in the form of Boolean algebra as A dot B is nothing but AND gate, not A dash is nothing but for NOT gate, and for OR gate is nothing but A plus B. So this is how these gates are represented in the form of Boolean algebra. Combinational logic. Combinational logic circuits are digital circuits whose outputs depends only on the current inputs. They do not have memory elements and produce outputs based on the combination of input states. Even these combinational logic gates do not have clock signals. Also, they do not have memory representation. So whatever is the input, there will be an output, and they do not depend on the past representations of input and output. So they change according to the input. Examples of combinational logic circuits are multiplexers, decoders and encoders. Decoders are nothing but if there are n input lines, there will be 2 to the power of n output lines. So for example, let us take 3 input lines. If there are 3 input lines in a decoder, the output will be 2 to the power of 3, that's nothing but 8 output lines. An encoder is the opposite of decoders. If there are 2 to the power of n input lines, there will be n output lines. For example, we can call 8 is to 3 encoder. So that there are 8 input lines and only 3 output lines. In case of multiplexers, there will be n input lines, m selections lines and 1 output line. For example, let us see 2 power 1 multiplexer. There will be 2 input lines, 1 selection line and 1 output line. So this is all about combinational logic. Let us see sequential logic. Sequential logic circuits are digital circuits that have memory elements. They have outputs that depend not only on the current inputs but also on the previous inputs and outputs, which is not possible in combinational logic circuits. This can be told as the major difference between combinational logic circuits and sequential logic circuits. Sequential logic circuits have memory elements and also they have clock signals, which is not present in combinational logic circuits. Examples of sequential logic circuits are flip-flops, registers and counters. These flip-flops, registers and counters will have clock signals and memory elements. So let us see ICs. What are ICs? ICs are miniaturized electronic circuits that contain multiple components on a single chip. AND gate, NOT gate and OR gate can be represented in the form of ICs. IC of NOT gate is nothing but IC 7404, and for AND gate it is IC 7408, and for OR gate it is IC 7432. So these types of ICs can be used in a breadboard to connect AND gate, NOT gate and OR gate. These ICs are widely used in digital electronics due to their small size, low power consumption and high reliability. ICs can be classified into various categories such as logic ICs, memory ICs and microcontrollers. Digital electronics applications. Digital electronics find applications in various fields including telecommunications, computer systems, consumer electronics and automotive industry. It is used in designing digital computers, microprocessors and memory devices. Digital electronics also play a crucial role in digital signal processing and data transmission. Finally, digital electronics is an essential part of modern technology. It enables the processing and manipulation of digital signals and information. Understanding the basics of digital electronics is crucial for anyone interested in the field of electronics and technology. So if you want to learn in details about digital electronics, you can refer this book, Modern Digital Electronics. You can refer this book, Modern Digital Electronics, 4th edition, written by R.P. Jain. This is all about today's video. If you want to know more about digital electronics and more about digital design and computer applications, please do like, share and subscribe to my channel. Thank you.